All right, everybody. Welcome back. We're going to jump in here with 9-1 Day 1, the first official lesson, Intro to Significance Tests. And today we're going to talk about two sports. We're going to talk about basketball, like the example we had last time, but we're also going to talk about football. So up here on the screen, believe it or not, is one of the most famous running backs in the history of the NFL. Played for the Bills, and I think he had one of the best, highest rushing yard seasons in a 14-game NFL season, over 2,000 yards rushing in 14 games. That would be Orenthal James Simpson, I think so it is, or O.J. Simpson. Now, most people don't know him for his football accolades. A lot of people have forgotten that he was one of the greatest running backs in the history of the sport. I think he still holds the NFL record for most rushing yards per game in a season. But he's known for something else. He's known for a very famous court case in 1994. And we're going to learn about something called a significance test, and it turns out that a significance test is exactly like a court case. So I'm going to be comparing what we're doing in class with this particular court case just for a little bit, but just court cases in general. So O.J. Simpson was accused of murdering his ex-wife and someone that was at her house, and it was just an absolutely horrific situation, and there was a lot of evidence that stacked up against him. They found his hair on a hat at the crime scene. They found a glove that has his blood and her blood, that he had a cut. There were all these things that matched up that, made him look very, very guilty. Like he was the prime suspect in the case. And we're going to get to kind of what happens if you don't know, but just know that when we're doing this type of activity, a significance test, the structure of it is exactly the way that the U.S. court system structures a court case. Okay, in a court case, there is a defendant. Okay, the defendant is the one that is, typically in the court system being accused of something, or they have a claim. Okay, we would call that in statistics the null hypothesis. It's often like the conventional wisdom of whatever's being tested. Okay. And then there's the prosecutor, and you guys as the scientists or the statisticians are testing, a potential alternative hypothesis to what's been said. So if Mr. Slagle, if I said that I was the 80% shooter on the free throw line, then that would be the claim or the null hypothesis for Mr. Slagle. Mr. Slagle claims he is an 80% free throw shooter, and so the statistician then says, Mr. Slagle, you are a math nerd. You went to school for math. I doubt you spent any time in the gym. That's what statisticians do to me when they pick on me. And so they're going to maybe suggest an alternative that says, Mr. Slagle, I've never seen you on the free throw line. I don't think that you're an 80% shooter, so they have reason to suspect that I would be maybe less than an 80% shooter on the free throw line. So just know that you have this defendant. That's our null hypothesis in the test, okay? And you have a prosecutor. Now, you've already done this. Activity. So you've done all this stuff. We just didn't come up with the names for it, okay? All right, so as we're kind of walking through this, if we're really looking at this, let's take a look at, in terms of, Mr. Slagle saying he's an 80% shooter. Our null hypothesis, which would be H naught, would be that the true proportion of my shots would be 80%, and the alternative hypothesis we would write like this: HA. Okay, so don't say ha or ho, say H naught. This is NAU. So the zero here, it's a zero with a number zero. NAUGHT naught. So the default hypothesis. So this would be that Mr. Slagle is actually less than an 80% shooter. Okay? There we go. Moving on. Okay, so what do we do in the court case? We have a defendant, we have a prosecutor. They bring evidence to the table. Okay, the prosecution brings evidence and witnesses, the defendant brings evidence and witnesses, or tries to tear apart the prosecution's argument. That's what happens in a court case. In statistics, we get something called a p-value, and it's going to be very important that we know how to interpret that p-value for tonight's assignment and moving forward in this unit and in this class. Okay, so we want to know, it's one of the most important interpretations for you to memorize. But that is the evidence that we want to collect about the claim that's been made. Okay. All right. So here we have this defendant. They weigh the evidence, and then they have to make a decision in court. And in court, they don't say, we find the defendant guilty, or it's not guilty or innocent. It's we find them guilty or we find them not guilty. Okay. It's based on what was claimed. Right? If they say the claim is that he's guilty, we either find him guilty or we find him not guilty. Now, not guilty, in terms of the O.J. Simpson case, he was acquitted, which means it doesn't mean he's innocent. It means that they couldn't find enough evidence to say that he was guilty. And there's a big difference. Saying not guilty does not mean innocent. And I know that it sounds like innocent, but that's not what it means. It means that there was not enough evidence to say that he was guilty. I don't have an opinion on the matter. I don't know enough about the case. A lot of it points to him being guilty, and I don't know if you guys can see some of this. Let me expand the page so you can see some of that there. So it's guilty or not guilty. In terms of statistics, guilty means we reject H naught, which means we had convincing evidence for the alternative. Okay? Not guilty would mean we fail to reject H naught, which means there is not convincing evidence for HA. We did not have enough evidence to support the alternative hypothesis. Okay? That's kind of what's going on and how that relates to a court case. So our two conclusions that we can draw are reject H naught or fail to reject H naught, not accept. We would never say accept H naught, we just say fail to reject. We did not find convincing evidence. All right, so let's do some definitions here. The null hypothesis is the claim that we weigh evidence against. Everything is weighed against that claim, and we assume that to be true. Okay, so in terms of this court case, it was that the claim is that he was the murderer of these two people. Okay, and so they have the burden of proof to try to bring forth the evidence that can convict him, right? And that was from the district attorney's office, is who the prosecutor was. Okay. The alternative hypothesis is the claim we're trying to find evidence for. So we have to, the burden of proof is on the prosecutor here to show that, that he was guilty. In terms of Mr. Slagle on the free throw line, if Mr. Slagle, we would assume that, I was an 80% shooter, and we'll say, okay, Mr. Slagle, we'll pretend you're an 80% shooter, right? And so we assume that's true, and then we go and collect some evidence, and we run into a problem, of course. Okay. So yeah, so what you need to know is the null hypothesis is always assumed to be true, and it always involves some parameter of interest. You must state the parameter of interest that we're talking about, and the parameter of interest in the case of me being an 80% shooter would be my true free throw percentage, Mr. Slagle's true free throw percentage. HA almost, or so not all, almost, it always must involve the parameter from H naught. You can't bring up some other parameter, so you're just always making a comparison. It'll be much simpler when you see this in an example. So, so common H naughts that we can expect here, all right, common H naughts are typically involve the parameters that we're going to use, which would be something like mu. We might say like mu is equal to 7 inches if we were measuring height. I just made this number up. It's not relevant to anything that we've discussed. Or we might say P, the true proportion of Mr. Slagle's free throws that he makes, is 0.8. That's the null hypothesis. You want to make sure you include units when you're defining the null hypothesis. And there are even, we're not going to do this in this class, but you can do these with standard deviations. So you can do you can test really any statistic with a hypothesis test. You can also do confidence intervals for any statistic. So these are different types of inference here. Okay. When you choose an alternative hypothesis, they fall into one of two categories. There are one-tailed hypothesis tests. Whoops. Let me zoom in here so we can see that. And I'm going to expand the page a little bit if you didn't see what I was writing because of my mug was in the way. So if there are one-tailed hypothesis tests and there are two-tailed hypothesis tests. And whatever you select, you need to make sure that you have evidence to suspect that's the one that you should choose, right? So like, because you've never seen me shoot a basketball, you might suspect that your alternative hypothesis might be that Mr. Slagle, I actually think you're less than an 80% shooter. If you ran into whatever, Steph Curry, and you were like, hey, I don't think you're an 80% shooter. I think you're more than an 80% shooter because they're in the NBA or something like that. So depends on who it is you're testing there, okay? In terms of, if we were talking about, let's say, the height of a chinchilla off the ground, then you might say, well, I actually think chinchillas, their average height is greater than 7 inches. Or I might say that, you might have a test that you think it's less than 7 inches, whatever. So your one-tailed test is always less than, greater than, and it involves whichever thing you selected here. So these are tied together strictly, okay? For a two-tailed test, we're going to talk more about this later. That just means instead of using greater than or less than, it's when you don't have any idea. Like, you suspect me to be a poor shooter, so we're going to test that it's, I think that Mr. Slagle's less than 0.8. But if you have no idea, any information about the person, you might do something called a two-tailed hypothesis test where you just say not equal to 0.8. Okay? I just don't think it's that. I think this person is lying or not telling the truth. Or if it's a mean, you might say I don't think that it's whatever, 7 inches. So these are the types of things that we write for hypothesis tests. All right. Before you begin, it's very important to set the stage and define the appropriate conditions for a significance test. So before you weigh your evidence, before you get a p-value, okay, you must first define what H naught is. So you have to define the null hypothesis. You have to choose and state, okay, make sure you choose and state H naught, HA, so you'd say H naught and then write what that is, and you say HA and you'd write what that is. And you also have to choose a significance level, alpha. Alpha Greek letter alpha is our significance level. Significance level. And for most significance tests, so I'll say this is usually 0.05. So it's usually 0.05. It's that 5%. And I've been saying, you guys were always asking, Mr. Slagle, how do we know whether or not we have convincing evidence for something or don't have convincing evidence for something? Well, it's always compared to that 5%. It's usually 0.05. And that goes back to some scientists back in the day saying, like, if you see something happen more than, 1 out of 20 times, it's probably for a reason. I forget his name, but anyways, it's important to do that. So let's go back to this shooter. Let's go back to this shooter situation. So I should have done this in the last video, and I didn't. But we're going to walk through kind of this whole process, and I did a simulation. So I put a true 80% shooter into an Excel spreadsheet, and I ran the test 251 times. So I had that shooter shoot 50 shots 251 times. So that's like a lot of shots in my Excel spreadsheet. And then every time that shooter shot 50 shots, I counted the number of makes that we saw. Okay, so I could write, this is so interesting, I could have written this 2 different ways, but really, if we were setting this up, we would have said, how would we have started? We would have said, what's our H naught? The H naught is that Mr. Slagle, I'm choosing me in this scenario. I am the defendant. I am making the claim that I am an 80% shooter. So we state our null hypothesis. We state the alternative hypothesis. Null hypothesis, which is P equals 0.8. We state alternative hypothesis that you guys don't think I'm an 80% shooter. Maybe some of you do. Thank you very much. Extra credit to you. Okay, and then we state our significance level. So we'll say, and I should also say, where P is the true free throw. So you need to define your parameter that you're testing as well. So make sure this definition exists, and then you will say we plan to test at alpha equals 0.05 significance level. So this is the state portion of the speedy process for a significance test. Okay, so we state our hypotheses, we state our parameter of interest, and we state our significance level. Okay. Yeah, this is a true, I can just write this out, true proportion of free throws made by Mr. Slagle. Okay, cool. So we've got those figured out. Then we go and we collect data and we get a sample. So you put me on the line, I go into the gym, and let's say I have you get the sample of that 32 out of 50 shots were made, which is a 64% shooter. That's what I was. Now we have there's 2 explanations for that, right? Either I told the truth and I was unlucky, I have an actual 80% shooter and I just got unlucky, or I'm not, I was lying, right? So let's take a look. Now, so if I ran this simulation of a true 80% shooter, the reason we say less than 80 here, the reason we look in this one direction a couple ways is because we want to see if I ran this simulation and we saw 32 happen a bunch, that would be nice, but really this point is just as convincing, right? So how many points looked like 32 or more extreme? And in this case, we only have 1. So this is what's called our p-value, the p-value in this situation, our approximate p-value is 1 out of 251. And I don't have a calculator in front of me, so hold on, let me pull up my phone really fast. I hope you guys can see the statistics here. Let me pull that up. Slide this over a little bit. Oh no, it's not going to show up. Oh well, I'll just pan down. Ooh. Okay, let's see. 1 divided by 251 is 0.00. So I get a p-value here of 0.00398. So it's really small, okay? And then how do we use this p-value? Well, we use this p-value to compare to our significance level. So let's go on to the next slide here. So here's what a p-value is. It's assuming H naught is true, which would be this. Assuming that Mr. Slagle is an 80% shooter, and here I'm graphing not the proportion, I'm graphing the number of shots made, but that's okay, we can still use that. It's the same thing, just divide by 50. Assuming H naught is true, it's the probability of getting results like the sample or more extreme just by random chance. So that's what we did. So how many of the results looked like mine, 32 out of 50, or more extreme in the direction of the null hypothesis? So there's nothing at 32, but there is something at 31. And so that still is evidence for the possibility of something that looks close to 32, if that makes any sense. So you always are looking in the direction of your null hypothesis here. So what's the true interpretation? It is assuming H naught in context, there's a p-value probability of getting a sample statistic in HA direction just by chance in a random sample of size n. Okay, so how do we, let's fill in the gaps here now with, sorry, I should have just done that, there we go. Let's fill in the gaps and make our statements by filling in the interpretation with the situation at hand. Assuming Mr. Slagle is an 80% shooter, there is our p-value was 0.00398. There's a 0.00398 probability of getting a p hat of 0.64 or less by random chance in a sample, just by random chance in a sample of size 50. So that's what we're looking at for our interpretation. Okay, so you guys can jot that down or go back and compare that if you need to. I'll say it one more time. Assuming Mr. Slagle is an 80% shooter, there's a 0.00398 probability of getting a 64% shooting average or less by random chance in a sample of size 50. So for an 80% shooter. Okay, cool. So here's how you do it. Basically, if the p-value, our 0.00398, is less than alpha, which is our significance level, which is 0.05, we reject H naught. And we say we have convincing evidence for the alternative. So it's very important to say we do not, we're almost to that point, but there's two statements you want to make. At the very end, our conclusion is since our p-value, 0.00398, is less than our significance level, we reject H naught, which means we reject the fact that I'm an 80% shooter. And instead, we have convincing evidence that Mr. Slagle is less than an 80% shooter. Okay? Up here, if our p-value, 0.00398, is greater than alpha, whoop, we fail. That should be fail. We fail to reject H naught. So there's a big warning here. We never say accept H naught, right? Just like we don't say that O.J. Simpson is innocent. We don't say that he's innocent. We just didn't have enough evidence to find him guilty. Okay? So if our p-value is greater than alpha, then our significance level of 0.05, and we can change this, we'll talk about that later, how we change this, but We fail to reject H naught, which means we don't have convincing evidence that I'm less than 64. And so, like, how many shots would I have needed to make if you go back and look? You know, if I had made 36 out of 50 instead of 32 out of 50, I don't even think I could make 32 out of 50. But if I had made 36 out of 50, well, man, I think that's more than 5% of our dots that are up here on the board. Remember, each dot represents 50 shots in the number of makes out of 50. So if I had hit 36 or 37, that is a reasonable amount for an 80% shooter to hit. Now, it's not great, but it's a reasonable amount. So that would mean we wouldn't have enough evidence to suggest that I'm not an 80% shooter. So just know that we never say except in these situations. All right, well, that's it for this video. Hope you guys enjoyed it, and I hope this is starting to make some sense. It's all compared to a court case, and the way that we start, them being so similar, I think, helps us understand them both a little bit better. The other key thing that I want to mention actually before I end the video is, I don't know if I stress this enough, before you get your p-value, you have to decide on all this stuff. And the reason is because since you make this judgment call, yes, your p-value is less than alpha, if you were able to choose alpha in the end, then you'd be able to choose the conclusion at the end. And so you don't want to do that. That needs to be chosen before you begin your study. Okay? Hope that made sense, and go ahead and try your best on the assignment. Feel free to email me with questions. We're going to talk a little bit more about this next time. Thanks for watching.